Now that we can record measurements to the appropriate significant figures and we can perform calculations with those measurements, now we need to look at what happens if we need to convert the units. This is called dimensional analysis. Dimensional analysis is a way that we convert units for any given property. I've presented this in an earlier page, but we're going to work it a little bit more now. So there are some conversion factors located in this table on the e-text, and some of these conversion factors, specifically those between common units or English units and the SI units, you don't need to memorize all of those. It would be a really good idea to memorize that 1 inch is 2.54 centimeters. It would also be a very good idea to know that 1 kilogram is 2.2 pounds. Beyond that, you should be given a lot of these conversion factors if you need to convert between SI units and standard English units. So when we work a conversion, as I showed you in an earlier page, we use these conversions as what are called equivalency factors. These equivalency factors can be represented as fractions, and we can use the unit if we treat the unit as if it is its own factor. And we know that when you have factors in standard computation, so if we had a fraction like 2/6, we know we can reduce 2/6 because the factors of 2 are 2 and 1, and the factors of 6 are 2 and 3. We can cross out the 2 that is in the numerator and the denominator to get the reduced fraction. Well, we do the same thing except with units. So when we do that with units, what we're saying is if we have 1 inch is equivalent to 2.54 centimeters, and I have 10.0 centimeters, then my centimeters are that factor. And as long as I perform the calculation correctly and my units cancel out, I should get the right answer. So I would have 10.0 centimeters times 1 inch over 2.54 centimeters. The centimeters would cancel out. Then I'm left with 10.0 inches divided by 2.54. I can do that calculation and end up with my inches. So let's work some problems here all the way through. The mass of a competition frisbee is 125 grams. We want to convert 125 grams into ounces using the conversion factor that we found. 1 ounce is equal to 8.349 grams. Well, we need to use that conversion factor as if it is a fraction. So it is an equivalent. So 1 ounce is the same as this. So when we put it in this dimensional analysis, we're effectively multiplying 125 by 1 to be in the denominator. And I want grams to be in the denominator so that they cancel out with grams in the numerator. That means 1 ounce needs to be in the every part of this calculation needs to be equivalent, essentially. So this is one equivalency factor. Now there's another method, and in some of my problem solving videos you'll see this. This is a method called building fences. And when it gets more complicated, as we will show down below, it's easier to see where the conversion factors come from. So I have 125 and I have 1. Now I'm going to put my units over here. I have grams and I have ounces. So I am going to treat them as if they are factors. The number value, I have 28.349. Then I have grams. So you see my grams are going to cancel out. I do this arithmetic, 125.1 divided by 28.349, and that is equal to, I get 4.4093, and it continues, ounces. But let's look at our numbers. This conversion factor, this is considered an exact number. This is a definition. So this is my measured quantity. It has 3 significant digits. The number of significant digits in the answer will be driven by the measured quantity. So because this measured quantity has 3 sig figs, I need to report 3 significant digits. Look next door to see if I round. So I would report 4.41 ounces. For this next problem, what is the density? We're going to convert the units of density. A 4-quart sample of antifreeze weighs 9.26 pounds. Well, in this case, we need pounds. So 1 pound is 453.59 grams, and that's in that table that I referred to. Let's see, quarts, we are going to need to convert quarts. So 1 liter is 1.0567, and that's quarts. So 1 liter is 1.0567 quarts. And now we can do our calculation. Now we need to convert these units, and we need to end up with grams over milliliters. So I'm going to start with pounds. And you know what? I'm going to do this the short way first, or the long way, depending on how you look at it. So first I'm going to convert my pounds. So I'm going to use this first equivalency factor. I'm going to put pounds in the denominator and grams in the numerator. And when I do that, I have 9.26. That's going to be times 453.59. And then I have my units. I have pound and I have gram. And that will be over 1 is my only number. Then I have pounds. My pounds are going to cancel out. And 9.26 times 453.49 divided by 1 is 4,200.2434 grams. Now this is a defined quantity. It is an exact number. So it doesn't get to drive the significant digits of my answer. Only my measured quantity does, and that's this quantity here. So I have 3 significant digits. Look next door. So I would call this 4,200 grams, except that doesn't show me 3 significant digits. So I must use scientific notation in this case in order to show that there are 3 significant digits to this measurement. Then I can convert the volume. So I have 4.00 quarts, and then I'm going to convert my quarts by using 1 liter over 1.0567 quarts. And that is going to be equal to, let's do it the same way. So I have my numbers, and then I have my units. Put that over my number, and here's my unit. So my units are going to cancel out, and 4 divided by 1.0567 is 3.785, and then it continues. Again, my measured quantity has 3 significant digits. This is an exact quantity. It is a definition. So I need 1, 2, 3 sig figs. I'm going to look next door, and I'm going to round that up because the rule I was given was 5 or greater. So this is 3.79 liters. Then I'm going to take those 2 values, my 3.79 liters, and my 4.20 times 10 to the negative 3rd grams, and I'm going to create the density. So 4.20 times 10 to the 3rd grams over 3.79 liters, and I get a value of 1,108 grams per liter. I have 3 significant digits in both of my numbers, so 1, 2, 3 is what I report. 1.11 times 10 to the 3rd grams per liter is the answer I would report. That was the stepwise method, so let's do it all at once. I know I want to end up with grams per milliliter. I have pounds per quart, so I put pounds in the numerator, and this is where I'm going to use the building fences method. Then I put quarts in the denominator. If you would rather write these out as fractions, you go right ahead. So now I'm going to use this conversion factor, and I'm going to convert my quarts into liters. So I'm going to put my quarts in the numerator and my liters in the denominator. That will cancel out my quarts and leave me with liters. Now I'm going to convert my pounds into grams. Remember, between each of these fence posts here, we have an equivalency. So this and this, they are different, but they are their own equivalency expression. So once I cancel out my pounds, then I'm left with grams. So what I have left to do is multiply 9.26 times 1.067 times 453.59, all divided by 4. And I get the same value I had before, 1,109. I need 3 significant digits. So I would report 1.11 times 10 cubed, and my units are grams per milliliter. So you see, I wasn't sure which one to call the long way and which one to call the short way. This is a longer calculation, but it takes a shorter amount of time. So let's work this one. While being driven from Philadelphia to Atlanta, which is a distance of 1,250 kilometers, we're going to use 213 liters of gasoline. So what is the fuel economy in miles per gallon that this car got? So we want to end up with miles per gallon. What we have are kilometers per liter. So we're going to take our kilometers, 1250, and we're going to take our volume, 213, and we're going to convert them. Now we already know that 1 liter is 1.0567 quarts. We know that from the previous problem. And then a standard conversion, which you may need to look up or refresh, is that there are 4 quarts in 1 gallon. So my liters have canceled, my quarts have canceled, now I have gallons in the denominator. That's what I'm aiming for. Now I'm going to take those kilometers and convert them into miles. In 1 kilometer is 0.62137 miles. So when I cancel out my kilometers, I'm left with miles per gallon, which is what I was looking for. So now I can just do that arithmetic. So I'm going to take 1,250, multiply it by 4, multiply that by 0.62137. Then I'm going to divide that number by the product of 213 and 1.0567. So I get an answer of 13.8034, and it continues on, and that is miles per gallon. Now we need to look at our measured quantities. So we have 3 significant digits in our distance. We have 3 significant digits in our volume of gasoline. So we can only report 3 significant digits. We look next door and it is less than 5, so 13.8 miles per gallon is what we would report. Now I also mentioned on a previous page how to convert temperature units, but we'll work them a little bit here, we'll review them a little bit here. Just as we convert other units, we can convert from between our 3 temperature scales, and we do have 3 temperature scales that we're going to look at. We have Fahrenheit, Celsius, and Kelvin. So you see the boiling water line for Fahrenheit is at 212 degrees Fahrenheit. Boiling water for Celsius is 100 degrees. Boiling water for Kelvin is 373.15 degrees Kelvin. The freezing point in Fahrenheit is 32 and 273 in Kelvin. So you see a Kelvin degree has the same difference, basically, as a Celsius degree. We use Kelvin mostly in chemistry, and that's because we can't have a negative volume when we start calculating gas laws. So that's the primary reason we use Kelvin a lot in Chemistry 1. Now you will be measuring in Celsius in the lab, and your thermometer is graduated to the nearest degree. That means you need to estimate one more digit, so every time you read Celsius in our class, you should be reporting to the tenths place. Now Fahrenheit is what we're used to, at least in the United States. That's how we're used to reporting our temperatures. Now to convert from Celsius to Kelvin is a very easy calculation. We're going to take our measurement in Celsius and add 273. That's a very easy conversion. Similarly, if we have Kelvin and we need to convert it into Celsius, we subtract 273.15. The conversion from Fahrenheit to Celsius and Celsius to Fahrenheit is a little bit trickier. Now, I have a difficult time remembering this conversion. I often write it down, and I would suggest you write it down as well for whenever you need to use it in our class. You will be allowed a page of notes for every quiz. You can have that conversion on every quiz. So the conversion equation is Celsius is equal to 5/9 of the Fahrenheit degree minus 32. So if you have to convert between Fahrenheit and Celsius, say for cooking, that's the conversion you need to remember.